Hello everyone, welcome to Josh Max channel. In this video, we are going to see for grade 12 standard CBSE Maths, chapter number 5, continuity and differentiability in exercise 5.1 12th sum. So already in the last video, still question number 11, I have uploaded the solution. So please do check. Now we can move on to the 12th sum. So the question is about find all points of discontinuity of f where f is defined by. So this is the given function. So we need to check at which point the given function is discontinuous. So here we can notice that two different functions are there. Okay, so throughout the real line, we are not going to use a single function. So two different functions are there. Now using the if conditions, let's break the real line. And we can see that here is one interval. So we are going to check if x is less than 1, whether discontinue is there or not, or it's continuous, we are going to check. Same way, if x is greater than 1, in this interval also we are going to check. And finally, if x is exactly 1, function is continuous or not, or it's discontinuing at x equal to 1, we are going to check. So while checking, no, if x equal to 1 means we have to check for what is the f of 1, exact value of the 1 we have to check. Not only that, the close values of 1, in the both left hand side, right side, the close values of 1 also, whether it's approximately that value is equal to f of 1 or not, we have to check. So the infinite close values are there. So infinite close values one by one we can't check, no. So what we can do with we can take with the help of the limit to find the approximate values, the close values of 1 in both left hand side as well as in the right side. Now in this interval, if x is less than 1, infinite real values are there. So we can have a common name. Let c be any real value. At the same time, c is less than 1. Now f of c value we have to find out, and close values of the c in the left hand side as well as in right hand side we are going to see. If all the things coincide, we can say the function is continuous in this particular interval. Similarly for this as well. So that means to find out the discontinued point, we must have the three cases for this particular sum. Okay, so now in case 1, as I told, we are going to take for the x equal to, any order is fine. I'm going to in this order. First I'm going to take for x equal to 1, whether function is continuous or not, I'm going to check. So if x is exactly 1, this is the case 1. If x is exactly 1, so exactly 1 means we must check f of 1. So from the given, if x is exactly 1, we have to choose the first function, that is 1 power 10 minus 1. So 1 raised to any value is 1. So 1 minus 1, so which is 0. Now the close values of the 1 in the left hand side also, we have to get the same result. Same right hand side also we are going to check. And before that, let's see, are we going to use for the left hand limit also f of x, and for right hand limit f of x are same or not? Let's see. See, left side close values are approximately 1, but it is less than 1. That means we are going to use the first function. Right side close values approximately 1 but greater than 1. So we are going to use the second function. So since different functions we are going to use, we have to find out individually. So left hand limit, right hand limit, separately only we have to find out, not together. So now left hand limit x is approaching to 1 from the left hand side f of x. So the suitable function is first one. So replacing f of x with the first function, that is x power 10 minus 1. Now applying the limit 1 power 10 minus 1. 1 raised to any value, 1 minus 1, and which is 0. Now right hand side close values of x. What is it? Well, let's see. Right hand limit. So limit x is approaching to 1 from the right side f of x. So suitable f of x, right side close values of 1 are greater than 1. So that means we have to use the second function. So limit x is approaching to 1. F of x, suitable f of x, let's replace. After applying the limit, we no need to carry this limit x is approaching to 1 and all. Okay, now let's apply the limit 1 square value 1. So now we can notice that here left hand limit, see f of 1, left hand limit is equal. But these two results are not equal to right hand limit. So from this what we can say? From this we can say that the function is discontinuous at x equal to 1. Okay, so as of now from the case 1 what we found, the function discontinuous at x equal to 1. So f of x is discontinuous at x equal to 1. Okay, let's also check for if x is less than 1. Okay, infinite values we have, no? So in this interval, whether function is discontinuous or not. Same way, if x is greater than 1, whether function is discontinuous or not. Let's check. Okay, now case 2, if x is less than 1. If x is less than 1. So less than 1, we have infinite real values. So one by one for each value, it's not possible to check. So I'm going to have a common name. Let C be any real value. Let C be any real value. At the same time, C should be less than 1. Now, so our C lies in this particular interval. So C lies over here. Now, to check the continuity, we must have f of c value. Okay, then left hand limit of the c, right hand limit of the c, all these three if coincide only, we can say throughout this interval. Okay, from the in this interval the function is continuous. That means there is no point of discontinuity in this particular interval, we can conclude. Okay, so for that f of c, where we have to find out left hand limit of the c, right hand limit of the c, all the three things is required. Now f of c. So what is the C condition here? Less than 1, no? Then suitable function from the given we have to choose. Less than 1 means we have to choose the first function, that is x power 10 minus 1. So in place of x we have c, no? That means c power 10 minus 1. Okay, so we got the f of c. Now left hand limit, right hand limit. So c is less than 1. Okay. Now the closed values of the c in the left side as well as the right side also, it's a less than 1. So that means here for the left hand limit different function we used, and here different function we used. But in this case, the closed values of the c from the both the sides, it's going to be less than 1. So we have to use the first function only. So instead of finding left hand limit, right hand limit separately, we can find it together. So now limit x is approaching to c f of x. So suitable function, first function, that is x power 10 minus 1. Now let's apply the limit. On applying the limit, the result is c power 10 minus 1. Now we can see that f of c and limit x is approaching to c f of x, both are same. So what we can conclude from this, the f of x is continuous in the interval, that is c, if x is less than 1. Okay, minus infinity to 1, the function is continuous. So let's write the same as a conclusion. F of x is continuous if x is less than 1. Now which we have to check for throughout the real line. Okay, so we checked x equal to 1, what happens if x is less than 1, we also check the continuity. Finally, if x is greater than 1, okay, for that we have to check the continuity. So in case 3, if x is greater than 1, so greater than 1 as usual, so infinite real values are there, so we have to take a common name. Let c be any real value. Let c be any real value. At the same time, c should be greater than 1. Now f of c, so greater than 1, from the given suitable function we have to choose. So if it is greater than 1, we have to choose the second function, that is x square. So here input is c, that means c square. Okay, so our c is greater than 1. Okay, so 1 is over here, c some lies between 1 to infinite, so it can be any value, 100 or 5, 1000, it can be any value. So f of c is, that is c square we found. Now the closed values of the c from the left hand side and right side we have to find out. So one thing we can understand, that the closed values in the left side as well as right side, it's greater than 1. So that means single function only we are going to use for the left hand limit as well as right hand limit. So instead of finding it separate, so we can find it together. So limit x is approaching to c f of x. So what is the suitable function from the given? If x is greater than 1, we have to choose the second function, that is c square. X square. So replace x square. Now apply the limit. On applying the limit, the result is c square. Now we can notice if x is exactly c, the result also c square. And the closed values of c, also the result is same c square. So from this we can conclude the function is continuous if x is greater than 1. If x is greater than 1. So from above all three cases, what we can say? So throughout the real line, is the given function continuous? No. At x equal to 1, function discontinuous. Okay, so only at one point the given function is discontinuous. For the remaining all the real values excluding the 1, the function is continuous. Okay, so already I have written the solution here. Okay, so thank you for watching, and please do subscribe. And the solution for the 13th sum will be continuing in the next video. Thank you.